Hey guys, so when we're looking at matrices, not matrices, my apologies, there are three main types of matrix that we will look at. So these three types, you can classify them as a row matrix, you can classify one as a column matrix, and then you can classify one as an ordered matrix. So the names are exactly like they sound, but if you're new to matrices, then this will be new to you. So when we're looking at a row matrix, this is a matrix that just contains one row and a number of columns. So when we talk about matrices, we know they look sort of like this. The things in them which go from, say if we had a system of numbers in here, say 1, 2, 3, 4, 5, 6. The rows is if we read from left to right across the screen like that. So 1, 2, 3, that is a row. So there's another row here, which is 4, 5, and 6. That's row 2. And then the columns are down. So this here is going to be a column. This here is going to be a column. And this here is going to be a column. So for matrices, rows go across and columns go downwards. So we can have a matrix that consists entirely of just one row, but a number of columns. So if I was to use these numbers 1, 2, 3, and 4, very creative, I know, and I was to make a row matrix, it would look something like this. So I would have a 1 here, a 2 here, a 3, and then a 4. And this is what we call a row matrix because it just has the one row, but it has a number of columns. So it's going to have 4 columns and 1 row. And when we're expressing the dimensions of this matrix, so we say this matrix has some certain dimensions, we express them using this RC. So rows and then columns. So because this is a row matrix, it is only going to have one row. And it has 4 columns. 1, 2, 3, 4. So we would say this is a 1 row by 4 column matrix. R by C, 1 row by 4 columns. It's a 1 by 4 matrix. We can also, I guess, look at what we call a column matrix. So a column matrix is going to be exactly like it sounds. It is just a 1 column matrix. So if I were to take the numbers 1, 2, 3, and 4 and I was to form a column matrix, it might look something like this. So I might put a 1 here, a 2 here, a 3 here, and a 4 here. And that is going to be what we call a column matrix. So it has this 1 column, so it's just got the 1 column, but it has 1, 2, 3, 4 rows. So 4 rows. And again, when I want to express this matrix in terms of dimensions, I can say it's a row by column matrix. So this notation never changes. The matrix is always of R by C. So if I was to say this is a row by column, I know it has 4 rows and 1 column. So I can say that this is a 4 by 1 matrix. And that makes sense because when we said we had a row matrix, it was 1 by 4. And if we have a column matrix, it kind of makes sense that it's going to be a 4 by 1. I can then also form what we call an ordered matrix. So if I form an ordered matrix is a matrix which has some, not just one row and not just one column. So if I use these numbers here to form an ordered matrix, I might get a matrix which looks something like this. So I might have a 1 here, a 2 here, a 3 here, and then a 4 here. So if I'm looking at my ordered matrix here, I know that it's got 2 columns, so columns equals 2, and it's got 2 rows. So if I want to express this matrix as a in using our matrix notation, I can say that this is a row by column again matrix, so this is never going to change. It's going to be a 2 row by 2 column. So this matrix here is going to be a 2 by 2 matrix, and that kind of makes sense logically. It's 2 by 2, so it's going to be a 2 by 2 matrix. So there are 3 types of matrices: row, column, and ordered matrices. They're going to become a lot clearer when we actually use them for addition and subtraction and some multiplication later on. But for now, just please be familiar with this R by C concept and the fact that when we're defining a matrix, we always write our rows first, and our columns second. So I'll put out some examples on this for you guys to have a go at. Thank you.